Hello, pharmacy students. Welcome back to Pharma Ed. Today, we're tackling a topic that is absolutely fundamental, not just for your exams, but for your entire career. We're talking about acid-base titrations. Trust me, you need to know this stuff inside and out, so let's get right into it.
So, have you ever picked up a medicine and wondered, how do we know for sure that this tablet has exactly 500 milligrams of paracetamol? How do we guarantee its purity and its dose? Well, the answer lies in a precise, powerful technique used every single day in pharmaceutical quality control. All right, here's our game plan. First, we'll cover why titration is such an essential tool for any pharmacist. Then, we'll dive into the core theory of acids and bases. After that, we'll look at the different types of titrations and their indicators, put it all into practice with some real-world applications, and finally, I'll give you some tips on avoiding common mistakes in the lab. Let's get straight to the point. Acid-base titration isn't just another lab exercise you have to get through. It is a cornerstone of pharmaceutical analysis. It's how we find out the exact concentration of an active ingredient. And that level of precision, well, it's completely non-negotiable when it comes to patient safety and making sure a drug actually works. Okay, before we start mixing chemicals, we absolutely need to have a solid grip on the theory. A clear understanding of acids and bases is the foundation for everything we do next. So let's quickly go over the key ideas that make titration possible. So what exactly is an acid-base titration? At its heart, it's a quantitative chemical analysis method. Imagine you have a solution of an acid, but you have no idea what its concentration is. To find out, you react it with a base whose concentration you know very precisely. You keep adding the base until the acid is perfectly neutralized. By measuring exactly how much of the known solution you used, you can calculate the concentration of your unknown sample. Simple as that. Now, you've probably come across these three big theories in your textbooks. Arrhenius talks about H+ and OH- ions. Lewis' theory is all about electron pairs. But for our purpose, for most of the titrations you'll be doing, the Bronsted-Lowry theory is your best friend. Just remember this simple rule. Acids are proton donors, and bases are proton acceptors. This proton exchange is the heart of the reaction. Great. With the theory covered, let's get into the practical side of things. A successful titration totally depends on choosing the right tools for the job. And by that, I mean picking the right type of titration and, crucially, the correct indicator. All right, everyone, this table is pure gold for your university exams, so please pay close attention. You can see the patterns, right? When you have a strong base in the mix, phenolphthalein is usually the go-to indicator. For a strong acid against a weak base, methyl orange is what you'll use. And notice that last one. We almost never do a weak acid versus weak base titration. Why? Because the pH change at the equivalence point is so gradual, there's no sharp endpoint. An indicator just won't give you a clear color change, making it useless for accurate results. So, how do these indicators actually work? Well, they're basically special dyes that are sensitive to pH. They change color within a very specific pH range. Take phenolphthalein, for example. It's completely colorless in an acidic solution. But as soon as the solution becomes slightly basic, around a pH of 8.2, bam, it turns that characteristic pink color. That color change is the visual signal telling us, stop, the neutralization is complete. Hey, just a quick pause here. If you're finding this helpful, please take a moment to subscribe to Pharma Ed, hit that like button, and definitely share this with your batchmates. It really helps us create more content for you. Okay, let's connect all this theory to the real world. In the pharmaceutical industry, this isn't just about passing a lab exam. It's about how analysts ensure the quality and safety of the medicines that millions of people rely on every single day. This slide shows the whole process in its simplest form. It doesn't matter how complicated the drug molecule is. If it has acidic or basic properties, its titration always boils down to this one simple, fundamental neutralization reaction. An acid plus a base reacts to form a salt and water. That's it. And the applications in pharma are just everywhere. For instance, we use titration to check the purity of a raw material like aspirin. We use it to quantify the exact amount of an active pharmaceutical ingredient, or API, in a tablet. It's even used to analyze formulations like antacids to make sure they can neutralize the right amount of stomach acid. It's a truly versatile and essential tool. And what about the math? Don't worry, it's surprisingly simple. The one formula you absolutely have to remember is M1V1 equals M2V2. So let's break it down. M1 and V1 are the molarity, that's concentration, and the volume of your known solution, the titrant from the burette.
M2 and V2 are the molarity and volume of your unknown solution, the sample you're testing. As long as you know 3 of these values, you can easily calculate the 4th.
All right, now for some really practical advice. Getting accurate results in the lab requires great technique and attention to detail. So let's talk about some common mistakes and how you can avoid them to make sure your analysis is spot on. There are 3 big errors to watch out for. First, parallax error. This happens when you read the burette from an angle instead of straight on. To fix this, always bring your eyes to the same level as the meniscus. Second, improper standardization. If the concentration of your titrant is wrong, all your results will be wrong. So be meticulous when you prepare your standard solutions. And finally, getting the endpoint wrong. Remember, you're looking for the very first hint of a permanent color change, not a dark, over-titrated color. Let's wrap this up with a final thought. Why are we so obsessed with precision? Why does one single drop matter so much? Because at the end of the day, that precision in your titration lab translates directly into patient safety. It's what ensures that every tablet, every syrup, and every injection has exactly the right dose to be both effective and, most importantly, safe. We've covered a lot on titrations today, but I'm curious, what other analytical techniques do you think are absolutely crucial in a pharmacy lab? Let me know your thoughts down in the comments section. And if you want to dive even deeper into this topic, I highly recommend checking out classics like Vogel's textbook of quantitative chemical analysis or Pharmaceutical Analysis by David G. Watson. They are fantastic resources. Keep learning, keep growing, and we'll see you in the next video on Pharma Ed. All the best for your exams.